Hello, I am Juan-Juan, your Six Sigma instructor, and today we're going to explain how to calculate process capability and how to create a capability six-pack in Minitab.
Juan, before we start, can I ask a question?
Sí.
Do you have siblings?
Sí, I have 3 brothers and 3 sisters. My sisters are Maria, Guadalupe, and Rocio.
And your brothers?
My brothers are Jose, Carlos, and Steve. Steve the dentist.
Steve, the dentist?
See, he's very good with teeth. Anyhow, let's start with process capability. Welcome back. Let's talk about process capability. There are several capability indexes, but in this video, we will review only 2 of the most common, which are the CpK and the PpK.
Juan, what exactly is process capability?
Good question. Allow me to explain. As we can see in this definition, process capability is the ability of the process to meet the expected specifications. The key word here is expected, because the expected specifications could be, for example, grouping dimensions, or the weight of the parts or components being produced, or any other output of your process. It is very important that your process output can be measured, because for capability studies, we need variable data. If your process produces attribute data, for example, good and bad parts, you need to convert that to variable data. When a process is capable, the distribution may look close to the ideal distribution in this picture. But as we know, every process has variation, and your data may look like this. So, process capability is a way to determine how process variation is affecting the process output.
Juan, what causes process variation?
The answer is simple. Everything causes process variation. Remember the 6M in a fishbone diagram. Variations in the machine. Variations in the manufacturing method. Variations in personnel. Variations in the measuring method. Variations in the raw material. Variations in the work environment.
Juan, how is capability calculated?
Easy. Let me show you the formulas. As you can see in this formula, the CpK is the minimum value between the CPU and the CpL. The CPU is calculated by subtracting the upper specification limit minus the mean of the sample and dividing all that between 3 times the standard deviation, while the CpL is calculated by subtracting the means of the sample minus the lower specification limit and dividing all that between 3 times the standard deviation. Please notice that the standard deviation in this case is called the standard deviation within. I will explain that in a second. For calculating the PpK, the formulas are the same, except that the standard deviation used is the standard deviation overall. I will explain that in a second as well. But before I explain about the standard deviations, I need to clarify that in some books, you may find that in the formulas for the CpK, the X bar is used instead of the Greek letter mu or mu, which is fine because usually the X bar represents the mean on average of a sample, while for the PpK it's more common to see the letter mu or mu. Now, let's go back to the standard deviations. As mentioned before, the CpK uses what some people call the variation within, or the standard deviation of the sample, or even the short-term variation. That's the reason CpK is called short-term capability. While the PpK uses the standard deviation overall, which is the variation overall of the process, or the standard deviation of the population, or the long term. That's the reason the PpK is known as the long-term capability. Let's review an example. In this example, we already use Minitab to calculate the mean of the 30-piece sample. By the way, a lot of people use 30 as a magic number. Also, we graph from the print the upper and lower specification limits. Using our formulas, we substitute the values for the upper specification limit, the mean, and the standard deviation of the sample. And as you can see, we obtain a value of 3.72 for the CPU and 2.07 for the CPL, which means that our CpK is 2.07 because it's the smallest of the two values. We do the same for the PpK, and we obtain a value of 1.67 because it's the smallest of the two values. And now, let's calculate the CpK and the PpK using Minitab. For this example, we're going to be using Minitab version 19. If you have a different version, your screen may look a little bit different, but the functions are basically the same. Notice that I already uploaded some blueprint dimensions. I ended up uploading the magic number of 30 readings for each one of the dimensions. So, to create your 6-pack report, you need to go first to the upper side area of your screen and click on Stat. Then go to Quality Tools and select one of the two options for capability. In this case, we're going to pick Capability 6-pack. There are 3 options as well. Pick Normal, because manufacturing processes are usually normal distribution. Then, in this screen, select the dimension that you want to do the capability study. Remember, you will need one capability study for each dimension if the dimensions are different. Then, include the upper and lower specifications, which you will find those dimensions in your print. Click OK, and voila, your 6-pack is done. You have options to send the chart to PowerPoint or to other applications. Also, you can double click in your report and you can see the entire report in one piece. I will cover how to read the 6-pack in a different video. And your CpK and PpK values will be in this area. Your report is done. Now let's go to the final thoughts. And here are my final thoughts. Capability indexes such as CpK and PpK are great tools to analyze the performance of a process. You can easily determine if the process data is centered or shifted to one side. You can also easily determine the spread and the distribution of your data. But what is a good capability number? Well, that depends on your manufacturing or customer specifications. The most common required indexes are a minimum of 1.0, 1.33, 1.67, and 2. But be careful. That doesn't mean, for example, that if your process has a PpK of 1.67, you are making better parts than with a PpK of 1.33. No, 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 no. Capability indexes are used to control the process, not the quality of the parts. Quality of your product needs to be controlled via gauges, vision systems, electrical testing, or other devices. That's it for now. See you next time, and until then, take care of yourself and each other.